All right, you guys. So we're going to talk about normal curves, otherwise known as bell curves. And I already handed you a handout and we kind of went over this, but for those of you that missed it, when we talk about the proportional area or the percents under a normal curve, what we mean is that the area under this entire bell curve all adds up to be 1 or 100%. And the normal curve is just a histogram. Like we've made histograms since we were little, right? Like over here, we make histograms. We have so much is between 0 and 1, and so much is between here and here, and maybe more between these two. And this is, oops, that was terrible. This is just a histogram, and this histogram is made out of rectangles. And you can find the area of each rectangle really easily by taking the height times the base, right? So in this histogram, if we added all of these up for a piece of data, we would get the area is equal to 1. And that's pretty easy to do with the histogram. Well, we could change this histogram to be a curve. This wouldn't be a normal curve, but it would be a curve kind of like that. All a bell curve is kind of a normalized piece of data where you can see we have these rectangles, but instead of being flat on top, we've just kind of made a curve. So the area under this curve is still going to all add up to be 1, all of it together, but we're going to use some tables and stuff to figure out those percents. Unless you want to do some calculus, we could integrate it, but I think for now we're just going to stick with our Z table, which we'll learn about next time. But for now, we're just going to talk about what do these percents look like, right? So there are some rules, and the first rule is between, right here is our mean, and that's a standard score of 0. That means there's going to be 15% of the data on this side of the curve, right? Like maybe I'll do that in red. And then it's going to be 50%. So that's 50%. Ooh, let me play around with some highlighting up here. And then over here, this, oh, that's nicer, isn't it? This is also going to be 15% because a normal curve has what we call symmetry. So each half is going to look exactly the same. If we folded it around that mean line, the middle line, okay, each half is going to be the same here. Okay, good. So 50%, 50%. But there's some other cool things that we do and that we know and that we'll just have to memorize is that between one negative standard deviation and one positive deviation, oh, it doesn't make a color in between yellow and green. Anyway, all of this here is 68%, and that's always going to be the case between one negative standard deviation. Each of these is a standard deviation. You have the sigma right there, okay, and one positive is always, that's always going to be 68%, okay. Then we know some other things. We know that all the way from the middle, oh, it does make different colors. Oh, that's cool. From -2 standard deviation to +2, oh, that's super cool, standard deviations. This is going to be, except it's all different colors because of the other colors, 95%, okay? And then last but not least, let's see if I can erase some of this. And we've cleaned it all up. Cool. Last but not least, we know everything from -3 standard deviations to +3 standard deviations. This is going to give us 99.72% of, not this out here, of all of our data. So anything on the outside is not going to be very common, right? It's going to be very rare to score this high if we're talking about a test. If this is the if on the mean, our mean is the average score somebody scored, it is going to be very rare for somebody to score all the way up here, but it'll also be very rare for somebody to score this terribly on the test too, okay? The majority of the data is going to be in here, and more as you get towards the middle. Most of the people are going to be in the middle of a normal curve, right? Okay, so what are some other things that come up here when we talk about the normal curve? What comes up is how you talk about the area. You can talk about the area as a percent. Sorry, while I erase this. So 0.3413, that's a percent, 34.13%. It's also a proportion, right? It's 34 out, if this was just 100 students that took this test, 34 would have fallen in there. So we talk about it as proportion, we talk about it as area. Percents we can also talk about as probabilities. What is the probability that you will score in this area? It's going to be 34%, and we'll get into that when we talk more about probability. I don't know if that'll be this year or next year, but probabilities are fun. So there's just so much you can do with the normal curve. We'll get a lot of questions like what percent on our tests and stuff, what percent of people will fall between 2 and 3 standard deviations, and that's going to be 2.14%. What percent of people will fall between +1 and +3 standard deviations, and that's going to be 2.14 plus 13.59. We can add them together, which will be 10, 11, 12, 13, carry 1, 5, 6, 7, 15.73%. Okay, so once you have this in your notes and take it down, you can always use it to find the different percents for things. What percent of people fall between here and here? We'd add all of that up. And don't forget, we also have to still add up these last two pieces, here and here, to make 99.72. I think it's going to be about 0.15. Well, it's going to be approximately 30 to 0.30% to get to 100. So it's going to be half of that, 0.0015, right? Or even smaller, 0.15%, right? This is it as a percent. This is how I would write it as a decimal, that very, very small piece right there. So please make sure you have all of this written down in your notes. Be very explicit by writing down all of these percentages, because we're going to use those moving forward, and you'll be able to use them on quizzes and things.